The next one is phase 3. Now, phase 2 and phase 3 is pretty much the same in terms of what? Data traffic. It is also spoke to spoke. The difference is the way you accomplish it. In this phase, spoke to spoke is accomplished by tweaking the routing protocol. For phase 2 is tweaking NHRP. So I'm working with NHRP to accomplish this. Let me explain this by doing the steps. I'm sitting on R4 and I ping 10.5. Okay. What do I need to do? I need to check my NHRP, my routing table first. Right? Routing table will tell me what? It will map over my 10.5 to the next hop. Agreed? And then in the routing, once the next hop is done, what's next? I need to now go into my NHRP and do what? Check the next hop resolution by looking in my NHRP table. The mapping that happened was 10.5. The next hop is 192.168.1.5, right? I'll put the number now rather than using next hop. And then in NHRP, I mapped what? 192.168.1.5 to whom? $50.5. Agreed? If you look at the packet, the inner header would have been this. The outer header, based on this mapping to this, but this one is really mapping to this guy, I will put in whatever my source is. I don't care about that. But this guy over here is really mapping to what? $50.5. Understood, guys? So basically what I'm doing is I'm mapping 10.5 to whom? 50.5, but via what? The control plane. This information about the internal network and the next hop and the next hop mapping to the public address by default is available at only one location. And that one location is whom? The hub. And the hub maintains that in two different tables. It has a routing table. We'll just work with two networks over here to keep it simple. It has 10.4 via what? 10.5 this guy, but the hub also knows based on the NHRP that this guy really is what? And this guy really is but it's in two different tables. Yeah. The hub has that information. Good. Now, when 4 wants to talk to 5, he would check 10.5 and figure out first the next hop, send a request, get a response back, and then map the next hop to what? This next hop would map to 50.5. Let me show you this so you guys are clear about that. If I go to R4, show IP route, EIGRP, to get to 10.5, what is my next hop showing? This guy. So the first thing I find out, figure out what's my next hop, and then I need to do an NHRP map for what? To get to 5, this is my public address. Is there any correlation directly? Because at the end of the day, what is getting mapped over is that if I want to go to this network, this is the public address. Isn't that true? I have an intermediate step to get there. Everybody follow this. I won't move forward if you don't understand that. It's very important that you understand that there's two things over here. And the glue, the attaching thing between getting from here to here is what? What is attaching these two guys to each other? Yeah, but what address is attaching 10.5 to 50.5? It is that the next hop, right? So to get to 10.5, go via 1.5. In order to get to 1.5, go through 50.5. So that's the link that is followed. Agreed? What if I could have my hub, which has all this information, tell me that if you want to get to 10.5, go via 50.5, because it has both the information. It can put that information together and send me this NHRP resolution. That way, I will avoid doing this. I will go directly. I'll have a mapping that says in order to get to 10.5 in my NHRP table, it'll have a 50.5. Understood? So I'm avoiding one step over here if I could do that. And that's what phase 3 is all about. It's not accomplishing anything different. What is the end result of phase 3? Take a look at phase 2 and phase 3. What does the first line say? It's the same. How do I do this? This is accomplished by the hub /NHS by creating a NHRP entry for the internal network, mapping it directly to the public network. And normally, what is it? Normal is this. 10.5 has a next hop of 192.168, 1.5, which in turn maps over to 50.5. This is normal, or I should say this is phase 2. Phase 3, 10.5 is mapped directly to 50.5. How? Don't worry about it. I'll show you how. Understand the concept. You guys are okay with this? So what do I need to tweak? NHRP. The first thing that I need to do over here is to make sure it's back to what? Phase 1 in terms of all the traffic should be routed towards the hub because hub has all the information. So over here, I'm going to say IP next hop, self EIGRP 111. When I do that, I'm back to the default phase 1, right? So if I go to router 5 now, show IP route, EIGRP, everything points to what? Hub. Yeah? If I go to 4, show IP route, EIGRP, everything points to what? The hub. Why do I want to do that? Because the hub is the only one that has both the information, all the information, the both tables, NHRP and the next hop, the actual next hops. So once this is done, now what I can do on the hub is issue a command under the tunnel saying, hey, listen, if somebody tries to go from point A to point B, create the redirection. The redirection is creating that shortcut. It is actually creating an NHRP map for the 10.5 network. Rather than creating the map and giving the map to the next hop, is creating the map directly to what? 50.5. Right now, do I have that information? Take a look at your NHRP and tell me what information do I have for 10.5. I'll go to 10 router 4 because I already have the map. Do I have a map for 10.5? I don't. But I know if I want to get to 10.5 based on phase 2, in order to get to 10.5, I would go to 192.168.1.5, and then my map was for this guy. I don't have a map for 10.5, or I did not have a map for 10.5. Now by doing this command, which command? I'm telling the hub to create that mapping where 10.5 would be an NHRP mapping for the public address. Well, when I do that, it sends that redirect to the clients. The clients will not accept it. Let me show you that. If I go to router 4 and try to do a trace to 10.5, I will get that mapping saying, hey, listen, 10.5, go via, because now I've changed it. It is, everything is going to what? 1 now, right? So it's not even 10.5. So if I try to go to 10.5, source of 10.4, it's going via 1. And because it's 1, next hop, it's always going to go via 1. Yeah? But what I'm going to do, although I have the redirect over here, so he's telling me, hey, listen, don't come through me, go direct. He's sending the redirect. The clients are not accepting it. Why? The clients need to be turned, the configuration needs to be turned on for it to accept that redirect. And that command is NHRP shortcut, take the shortcut. So on the hub, I do redirect. On the clients, I do shortcut for it to accept that. And once it accepts it, I'll show you what it does. Now that I have accepted the shortcut, I'll do the same trace. But before I do the trace, I'll show you my NHRP mapping. I only have a map for 192.168.1.1 and 192.168.1.5, right? Now I will do a trace to 10.5. Still goes through 1, but now that the redirect has come in my NHRP table now, I have a map for 10.5. What does it say? I didn't have a 10.5 map before. 10.5 next, what do you call it? The outside address is what? 50.5. I have mapped this direct to this guy. So although my routing table says what? 10.5 via what? 192.168.1.1. When I try to do the trace route, NHRP caching, it affects your fib, it goes faster and goes direct. Although it says go through 1, you see this, what do you call it? Symbol over here. The symbol signifies the next hop has been overwritten. I'm going direct. So it's not going through here, it's going directly to 5. You might say, well, you did the same thing with the next hop. Yes, I did, but this is much quicker. I don't need to do 2 lookups. I'm just doing the NHRP lookup, which basically is telling me my next hop to 10.5 is directly to what? 1.5, or going directly to the device. You understand that? What did I do to accomplish this on the hub? IP, NHRP, redirect. On the clients, under the tunnel interface, IP, NHRP, shortcut. The most common spoke-to-spoke mechanism is this one. Why? It actually makes it efficient to forward the traffic. It's not just spoke-to-spoke traffic. It is also a more optimized way of doing it because of what? Notice this. I'm doing a map and then a map to a next stop, the next stop to the public. Here, I'm mapping directly from the destination to the public. And you can see that over here in my NHRP table. 10.5 directly to what? This guy. Correct. That is correct. Which tunnel, Mazen, the spoke or the hub? From the hub, it is the map multicast network. The only extra thing that I did over here was the NHRP redirect. On the clients, yeah, that meeting I miss, Amod. Sorry. On this guy, you just do shortcut. In terms of, Arun, in terms of the packet in phase 2 and phase 3 is identical. It won't change. So whether it's phase 2 or phase 3, my packet from 10.4 to 10.5 will still look like this. Okay, so this doesn't matter. It's going to be the same. It's just the way I arrive at that. It will in the VIA. Yes, in your NHRP, you'll see it, but you won't use it because it goes directly. How's it more efficient, Trips? Do you see this? I need to map from here to here, here to here. Here, I'm doing it directly. I need to check the routing table first. From the routing table, I check the NHRP. Here, I check the NHRP directly and it goes faster. And your thing, Arun, was checking this is what you wanted to see. It does give you the tunnel via, but I don't care about the, no, not this one, sorry. This one, 10.5, it shows you the via, but mapping is this guy. Is this what you want to talk about? This is what you wanted to see, right? Yeah. The other advantage, guys, is this. In phase 2, if I had a large network, I need to send all the networks that I get to each and every individual device. Why? I'm using my routing table to figure out what the next hop is. Remember I said no IP next hop self, right? So on R3, I would need to see 10.2 in my routing table so I could figure out what? That I need to go through 1.2. And I would do a resolution for this guy because I'm looking at what? My routing table in phase 2. You guys understand this? You guys agree on this? Before we move forward, make sure you have established this. In phase 2, because I'm working with a routing table, in my routing table, I need to have every network and its corresponding what? Next hop. So it would send it to the appropriate device. Agreed? Because I'm using the routing table to figure this out. Otherwise, I would go everything through the hub. In phase 3, routing table is overwritten. By whom? By the NHRP redirect. So because of that, one of the things that you can do is, if you want to, I can go to router 1, the hub, and I can go under the tunnel interface and I can create a summary address. I'll say for EIGRP 111, summarize the 10 network. So I'm not going to send them all the routes. I'm just going to send them network 10. Or you can do a default route for that matter. With phase 3, okay, I'll show you one and then we'll do another one. Now take a look at your routing table. I don't see what I don't see 10.1, 10.2, 10.3, 10.4. I just see a summary route. Now, if I want to go to 10.3, 10.4, 10.5, everything is pointing to 1. In phase 2, I could not do this because I need to have 10.2 point to a different one, 10.3 point to a different one, 10.5 point to a different one. But this guy, if I go to 3, because I have that NHRP redirect, take a look what happens. First thing is the resolution. It always goes through the first hop. And then what happened? It went direct. How come did it go direct? In my routing table, it says what? Go through 1. Because if you look at your NHRP, it has created a NHRP mapping for 10.3 via what? 30.3. So it's not even looking at the routing table, it's looking at the NHRP. So now I could do route summarization of the hub, cut down on my routing table on the spokes completely. And if you really want to take advantage of that, I'll get rid of this and I'll do a summary route for EIGRP 111 as 0000, 0000. And what does that do? That even further cuts down what? What happened? Didn't it get a default route? Oh, I have a static route. I can't do that because I have a static route over here. This static route overrides the EIGRP static route. So this is not possible over here because of this default route. So this would not work, but at least I could do this. Rather than sending all the specific routes, I could summarize EIGRP 111 to the 10 network. So just one route for the 10, EIGRP summary address for EIGRP 111 for the 172.16 network. So now if I go to 4, I have one 10 network and one 16 network, but I can go anywhere I want direct. 10.2, first time going to the hub, second time direct. 10.3, I think I had done 10.3 already, so it might go direct because once no, I haven't. So again, and then 10.5. So even though I just have a summary route, I still can go direct. I could not do this with phase 2. So that's the other advantage that I gained. I can do route summarization on the hub to make my routing tables on the spokes concise. This is available for phase 3. So as a recommendation, if you're running DMVPN, run, and you want spoke to spoke, run it with phase 3. And how do I configure phase 3? Once I have the base up on the hub, redirect on the client's shortcut.